Let's discuss about electric dipole. Our new topic is electric dipole. Electric dipole. It is a system of 2-point charge equal in magnitude and opposite in nature, separated by a very small distances. So here a electric dipole is shown. One is a plus q charge and minus q charge, and it is separated by a very small distance. Here it is taken as 2L, or you can take 2A, plus and minus q charge. Now dipole moment. It is the product of magnitude of one charge, any one charge, with the separation between the charge. It is denoted by P if magnitude, or P vector in vector form, and given by P vector equal to Q into 2L vector. The direction of L vector or P vector is from negative charge to positive charge. In magnitude form, P equals to Q into 2L. It represents magnitude of dipole moment. And unit of dipole moment is coulomb meter. From here, Q is coulomb and L for meter, so coulomb meter. Practical unit is dBA, represented by D. And 1 dBA is equal to 3.3 into 10 to the power minus 30 coulomb meter. Dimension, that is dimensional formula of dipole moment P equals to dimensional formula Q into 2L. Now dimension of dimensional formula of Q is Q and length is L. This is in the unit MKSQ system, and this is SI unit AT into L, because Q is equal to AT. Find net electric dipole moment. Here a system of charge is shown, and we have to find the net electric. Here minus 2q charge, so one minus q charge will make dipole with this, and another minus q charge will make dipole with this. And because it is equilateral, so angle is 60 degree. Now we can calculate P net. Here it is shown P vector and P vector. So under root P square plus P square, 2P into cos 60, and 2P square into 2P square cos 60. Taking common, under 2P square into 1 plus cos 60, and 1 plus cos theta is equal to 2 sin square theta by 2. So 2 under 2P into 1 plus cos 60, under 2P into under root 2 into sin square 60 by 2, or root 2P into root 2 is sin 30 degree, or root 2P into 1 by 2, or 2P into 1 by 2 equal to P equal to QA. Answer. P equals to QA. Answer. Now dipole in electric field. Now we have to learn the effect of dipole when it is placed in an electric field. Electric field may be uniform and non-uniform. So first we see the when it is placed in uniform electric field, what happens. When the electric field is uniform, here it is shown by field lines. The electric field lines shows that there is a uniform electric field, because lines are equidistant. And uniform electric field lines are uniform electric field is represented by uniform electric field lines with constant spacing. So here this diagram represents uniform electric field, and now a dipole is placed in uniform electric fields. One is positive charge, and we know that dipole is a system of two charge with opposite nature, so plus q and minus q. So force will be on positive charge will be along the direction of field Fe, and in this direction Fe, but the direction is opposite to each other. Force direction is opposite to each other. So if on this whole system, net force will be equal to 0, because force are equal in magnitude but opposite in nature. And torque net will be 0, because there is no torque in this case. Again, in this case, if dipole is not along the field lines, that is, it is displaced at angle theta with the field lines, then what happens? We have to see this condition. So force on positive charge will be in this direction, force on will be this direction. If, and we have distance between them as 2L, and we are taking the midpoint at O. So this distance will be L and this distance will be, and this angle is theta. So here net force again is 0, but torque net will not be equal to 0 because there will be a torque about, we are taking torque here about O. So torque will not be equal to 0. When a dipole is placed parallel to the field, it will experience no net force and remains in equilibrium state. Also the net torque is 0. If the dipole is slightly rotated from equilibrium position, it again experiences no force, but the torque will be acting and is given by tau not equal to, that is tau, we are taking tau about the point O, in this case here this point. So tau equal to R1 cross F1 and plus R2 cross F2. Now this distance is represented at R1. Here this tau 0 equals to tau not equal to, or tau O equals to R1 cross F1, R2 cross F2. This distance is R1 and this distance is R2. We are taking distance from origin. This is angle theta and this is angle theta, and force is acting in this direction and in this direction. If we consider this as F1 vector and this as F2 vector, because direction is opposite, so we are taking force as another direction. So tau 0 equals to R1 cross F1 plus R2 cross F2. Now composing, we are taking R1 in the component form. So L cos theta I plus L sin theta j cap cross F1 vector will be Q into E into I cap plus R2 into component for minus L cos theta I cap minus L sin theta j cap cross Q into minus of I cap. So finally we solve it. So first multiply cross product of this and this. The L cos theta into QE I cross I, L cos theta QE I cross I. Again L cos theta and L sin theta j cross I, L sin theta into QE into j cross I plus, again this will be multiplied, minus L cos theta into QE minus of QE into I cross I, again minus of L cos theta into minus of QE into I cross I, and minus plus minus of L sin theta and minus of QE into j cross I. So I cross I is equal to 0, same vector, cross product of same vector is 0. So this term and this term will be 0, we are only left with this term, and j cross I is equal to minus of k cap. So we can write this will be added, because L sin theta q, j cross I equal to minus of k cap, and it will be also minus of k cap, and this will be multiplied to give positive. So this minus this will be, so 2 will be added because both are same. So will be added to 2L sin theta QE minus k cap and 2L into Q E sin theta minus of k cap. So we can write tau torque about O, that is tau equals to PE, because 2L into Q is P, magnitude of P, P E sin theta under minus k cap, or tau E we can write it as in vector form P cross E, because if we take cross product of P and E with considering its direction, we will get this value. So tau 0 equal to P so tau will be tau equal to P sin theta, where theta, and tau 0 equal to P cross E, and where theta is the angle between the dipole moment and electric field. Thus, when dipole is rotated in counterclockwise direction, whereas torque is acting in clockwise direction, here we see that. So it is of restoring behavior. Next, when the electric field is non-uniform, here it is shown in a situation. Electric field is not uniform, that is value of electric field changes with distance. So we have another force on positive charge and another portion F2. Magnitude are also different. So F net will be in vector power F1 minus F2. In magnitude it will be given as F net equal to P into del E by del X. And tau vector will be P sin theta of minus k cap, where E vector will be E1 vector plus E2 vector by 2, and E equals to E1 plus E2 by 2, because E1 in both electric field had same direction, only differs in magnitude. So E1 and E2 are in the same direction, only differ in magnitude. Now SHM of dipole. Consider a dipole is placed parallel to the field. If it is displaced by an angle theta and then released, it will experience a restoring torque and dipole will perform SHM. So this is the condition. Initially it was along the field direction, but when it is displaced by angle theta, it experiences force in it experiences torque, and torque behavior is to rotate, make it along in the same along the field direction. Now net torque on the dipole will be about O equals to P sin theta. For a small theta, tau O equal to P of minus theta. Negative sign is taken due to the restoring torque. And we know that torque is equal to the I omega. So we have written I O into omega d2 theta by theta square, or P into minus theta. Negative sign is taken due to the restoring torque. I0 and IO equal to d2 theta by dt. Here I0 represent moment of inertia and d2 theta represent d2 theta by dt square represent alpha. Tau equals to I alpha. So not omega, I alpha, sorry, I alpha. So alpha is d2 theta by dt, mean angular acceleration, and this is moment of inertia about O, and this is angular acceleration about O. So P into minus of theta on d2 theta by dt square equals to PE into E by IO into minus theta. So here we see that omega 0 or omega O square will be equal to P into E by IO, and omega O equals to under root PE by IO. If this implies 2 pi by T under root PE by IO, or T, hence T will be 2 pi under root IO by PO into E, PE into E. So this is the formula for time period of oscillation. Now if we consider that it is connected with rod, then we have to calculate a moment of inertia. We have P equal to QE into 2L, and IO will be ml square plus ml square due to if the charge has mass m and it is connected with length that is of 2L rod, then it will be one term also will add 1 by 12 mr into 2L square, where mr is the mass of rod. So I0 will be, IO will be 2ml square plus 1 by 12 mr into 4L square, or 2ml square plus 1 by 3 mr into L square. If mr equal mass of rod equal to 0, that is the rod connecting the two charges is 0, then I0 will be, IO will be, moment of inertia about O will be 2m into L square. Next, calculation of force acting on a dipole in non-uniform electric field. Here a dipole is placed in a non-uniform electric field. Field is due to this charge plus Q, and here it is dipole placed in this field along the line. So this is, if consider this is positive charge, is negative charge, so field will be more on this charge and less in this charge. So F1 we write F naught equal to F1 minus F2, 1 by 4 pi epsilon naught Q and Q2 R minus L to the whole square minus 1 by 4 pi epsilon naught QQ R plus L to the whole square. because distance r is taken from the midpoint of dipole. So for q into q by 4 pi epsilon naught, q into q by 4 pi epsilon naught under bracket 1 by r minus l to the whole square minus 1 by r plus to the whole square, or q into q by 4 pi epsilon naught r plus l to the whole square minus r minus l to the whole square r square minus l square. Solving, we get 4q into q by 4 pi epsilon naught into 4rl by 4 pi epsilon naught r square minus l square to the whole square. Now as if l is very less than r, so f net will be 4q into q by 4 pi epsilon naught 4l by rq, or q into 2l into 1 by 4 pi epsilon naught 2q by rq. So we can write f net equal to p. Here it is shown P into del E by del R, because if we can calculate del E by del R, then will be del E by del R into 1 by 4 pi epsilon q by r square. This will come out of the differentiation. Q by 4 pi epsilon naught a minus of 2 to the power 2 into r to the power minus 3, or minus 2q by 4 pi epsilon naught rq, and q into 2l is p. So we can write directly formula as a f net equal to p into del E by del R. Next example 2. Here is in this direction. The direction of electric field is in this direction. So it will experience F1 and this will experience F2. And this is plus Q charge. So this distance will be L cos theta, and this distance will be L sin theta. So F net equal to F1 minus F2, or QQ by 4 pi epsilon naught 1 by this will be R plus L, that is R plus L cos theta. This will be, so 1 by R plus L cos theta to the whole square, minus 1 by R minus L cos theta to the whole square, or Q into Q by 4 pi epsilon naught R minus L cos theta to the whole square minus R plus L to cos theta to the whole square divided by R square minus L square cos square theta to the whole square. Or solving for Q into Q by 4 pi epsilon naught minus of 4 into R L cos theta by R square minus L square cos square theta to the power 2, or Q into Q 4 pi epsilon naught 4 R into L cos theta R square minus L square cos theta in this direction. As L cos theta is very well less than R, so we have L square minus L square cos square theta to the power 2 will be equivalent to R to the power 4. Thus F net will be Q into Q by 4 pi epsilon naught 4 R L into cos theta by R to the power 4, or 2QL into cos theta, 1 by 4 pi epsilon naught to Q by RQ. So we can write P cos theta del E by del R. So F net will be del E P cos theta into del E by del R. For example, here a linear charge density is of rod length is given. This is a charged rod with linear charge density lambda, and we have to find the force on electric dipole. So E will be lambda by 2 epsilon naught R, or del E by del R equal to minus lambda by 2 pi epsilon naught R square. Hence mode of del E by del R lambda by 2 pi epsilon naught into R square. Now we know that force will be F equal to F P into cos theta del E by del R. Here theta equal to pi. So mode of F equal to P into lambda by 2 epsilon naught into R square, or Q into 12 by lambda by 2 pi epsilon naught R r square. This is the formula. Next, in this case we have to find the force on the dipole moment. This is q dash and q dash, minus q plus q dash, and we have a circular ring. So EP will be 1 by 4 pi epsilon naught, that is electric field at point P, 1 by 4 pi qx by r square plus x square by r square to the power 3 by 2. So del EP by del x equal to q by 4 pi epsilon naught del by del x under x by x square plus r square to the power 3 by 2. So taking differentiation, q by 4 pi epsilon naught x square plus r square to the power 3 by 2 delta x by del x 1 and minus again x is common, x into 3 by 2, and its differentiation will be x square plus r square to the power 3 by 2 minus 1, and again its differentiation 2x divided by x square plus r square to the power 3 by 2 to the whole square, and q by 4 pi epsilon naught, this is x square plus r square to the power 3 by 2, and 2x 2 cancel, x square 3x square, so minus 3x square into 3 by 2 minus 1 equal to 1 by 2. So x square plus r square to the power 1 by 2 divided by x square plus r square to the power 3 by 2. Now, so we can write F equals to P cos theta del E by del x. So P cos theta will be q dash into 2l cos 60, q dash into 2l and cos 60, 1 by 4 pi epsilon given by this value.